Okay, let's go ahead and go over the STL.
Whoa, hold on. What is going on? This is not looking right. What you do? Yeah. You changed up the PowerPoint slides.
No, I just took this from someone else. Yeah, steal from the best, man. I'm not going to read it at work.
All right.
That's just craziness. Wait, but did I record that?
Yeah.
I did. Okay, good. We'll just leave it. All right.
Yeah.
This came from Underwood. So there's my citation. No, it's not plagiarism. All right. Okay, standard template library. We've talked about this a little bit, so hopefully the beginning of this will be straightforward, and we'll probably just cruise through all this. The lab today is basically taking some STL code I've written and fixing it. All right, standard template library. You have containers, holds data, algorithms, does something to that data, and iterators. Did y'all do iterators in Java?
Yeah.
Just iterating through stuff?
Yeah, you iterate over stuff. That's all it does. You did it?
No, we didn't do it, but like, isn't that the stuff we already do all the time? Iterate?
Yes, but did you have a separate class to do all the iteration? No. Okay, so iterators will be new. All right, container is a way to store data. Okay, I said that. Algorithms, great. Iterators, generalized concept of pointers. They point. Oh, right, that's complicated. Makes more sense when you see it in action. I don't know if this picture actually helps y'all. Well, you can see that the container holds objects, aka data. An algorithm can perform something on that data, and it uses iterators to do it. Okay? All right. Yeah, it doesn't. All right, common containers. Vector, hey, a one-dimensional array. We've all done that, right? Good. List is a doubly linked list. A DQ is a double-ended queue. Really just a doubly linked list. You can point to both. You have the queue and the stack. To implement the queue and stack, we've already talked about. A set. What's the difference between a list and a set? What's that? So a set, yeah, you only have unique elements, aka no duplicates. Yep, no dupes. And a map is an associative array, which we will talk more about when we get into hash tables. But those are the common ones. So sequence containers, they like to classify different types of containers. Sequence holds them in sequence. As you can see, an array or a vector in a linked list, you hold items in sequence. But a binary tree, that's not exactly the case. So you have different example of sequence containers. Yeah, list and DQ are as well. Great. So associative container is not sequential, but uses a key to access the elements. Do I have a picture of this? Sure don't. Okay. All right. Let's see, what's the easiest way to explain this? 5 seconds. All right. Did y'all do hash tables or hash maps? We use them? We talked about them.
We said they're a thing.
They're a thing.
I know they got keys. That's what I heard about.
I know I wanted to use them in this class.
What's that?
I know I wanted to use them in this class.
Yes.
All right. So with a standard array, I'll just call it array, you would have array sub 0 equals, I don't know, 5, maybe array sub 1 equals 7, array sub 2 equals 8, dot, 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 dot. Am I on the board? Great. Okay. Key things, takeaways here. Since this is a pointer, these elements are stored sequentially, correct? All right. What we could do differently, any of y'all taking scripting? All right. With our array so far, what has to be inside the solid brackets? An integer. In other languages, you may have done something different. Still on the board? Great. You might have array sub John equals, and then maybe we have his good old social security number.
Oh, yeah, this.
Okay? And then maybe we'll do the same thing for, what's another good one? George. Okay, now, morning. Are these stored next to each other?
Not necessarily.
Not necessarily. So this is what they're talking about with a associative array. That is the term they used, right? Good. Associative containers. Bless you. You're associating the key. That is the weirdest Y. Key with a value. All right. You can think of it a regular array. The key was an integer, but it's not really a key. It's really an index because you're jumping to a memory location. Over here, it's taking the key and using the key in order to find the value. Over here, you just did that with jumping to the memory location, but now you're going to have to run some algorithm on the key in order to figure out where this value is stored in memory. So that's why it's associative. You're associating a key with the value. All right. We will talk about how this is done when we go to hash tables, which is actually the next lecture. But you understand the high level what's going on here? Okay, great. Where's my slides? Good. All right, that's nice. So a set, you can also think about a set is associative because while it stores a list of items without duplicates, it doesn't have to store them in any particular order. You just want to know if it's in there or not. Okay, vector containers. Did we do this in class? I'm pretty sure we did. Let's go find out. Maybe we didn't. Ooh, this looks sadness. No. No, I guess not. Okay, cool. We'll create a vector.cpp. All right, include IO stream. Probably shouldn't spell include correctly. And we'll include vector. Int main, int argc, char star argv. All right, let's see how we're doing. Okay. All right, so we can create, sure, let's do it that way. Int array. All right, give me some numbers. 5. 18. 14. 32.
100.
All right, we're good. Let's see. Okay, and all right, sure, we'll do it that way. So if we did cout I array dot pop back, what number do you think we'll get? Or will it even compile? Well, that's a good question. We should do that first. Nope. Missing argument. Ah. Probably should tell what type of vector it is, right? Since it's templated. Details. Whew! That was beautiful. Here's the error novel. 1 second. Oh, you like the novels the best? I call it the error novel.
Oh, I call it the wall of text.
Oh, I see what we did wrong. This is not how you do it here. So when you initialize the vector, you give a pointer to the beginning of the array and a pointer to the last element of the array, if you want to initialize it with a standard array. And then it just figures it out from there. All right. See, we'll compile now? Almost. Okay, hold on a second. Probably doesn't like the pop back. Here it is. Yep, because pop back is a void function. So let's do it this way. All right, now what should it print out? Sub 4. 100, okay. Oh, good. 100, great. And then if we pop back, what should it print out? Oh wow, it's not going to work out.
Yeah, it'll
Maybe it'll probably still say 100. Yeah. Yep.
Well, is your function for the last element?
That's a good question, but let's push back 56 just to show what's going on. There, now it worked. Why did that not fail? Probably because it didn't deallocate that memory and then everything was okay. Right? Yeah.
Okay.
Array bounds checking, who cares? All right, what else do we have here? Okay, great. So I showed that real quick, good. Okay, the way you iterate over a vector the old school way, int I equals 0, I is less than I array.size, I plus plus. We'll go ahead and copy this over. The old school way. And then let's go ahead and give it a good old \n down here. All right, and then that should, yep, all the way up to 56. All right, so that's the way you probably used to iterating over it. Notice vector has functions because it's an option or an object. So you can call .size and figure out how many elements are in it. We can use an iterator, or can we? Oh, we can use a way to pop it. Okay. Let's do that with a, let's do our different print functions. Void print old. We're gonna do snake case now. Vector int. Let's do D3 down. Just putting up here in a function so it can be easier. Print old I array. Didn't like that. Right, because it needs to be std. There we go. And we'll also do print, how should I call this? Print via pop. You okay, Ryan? Probably should make this correct. All right. So while I array, oops, empty, of course we need to say while not empty. And what was it? Get the back? Yeah.
Missed a line empty.
Ah, oh, better than the compiler. I don't want to do
I
this.
wonder how much money there is to be like a programmer spell checker.
What is this?
Not too much, but code reviewer is good. Print off the back.
A very specialized code.
That is what I'm really good at.
You only check comments and variables.
Yeah, it needs to be a function. Very good. So we'll call the back and then call pop back. And let's see if that, right, so it should print it out twice now. Whoops, I should probably save it. Oh, we'll print it in reverse. Yeah, that's true. I did print it in reverse. Yeah, you could do front, but then you'd want to do pop front. And then, yeah, that would work that way. Otherwise, that would be real. Yeah. All right. So constructing a vector, you can tell it to create how many elements you want. You can give it, pass it a default constructor for everything. So if you had a vector of dates, you could pass it what all the dates should be initialized as. And then you can also just pass it another vector and make a copy vector. Similar to how all your labs have worked so far. All right, iterators. In C++, iterators works a little differently than in Java, although they're doing the same basic concept. Iterators in C++ are pointer-like. They're used to access individual elements. Often they're used to move sequentially through some container, element by element, aka you are iterating through the container. Notice we have done this so far with up here, well, we have int I equals 0 up to the size, and we're iterating through every element. but we're explicitly jumping to every element inside of this loop. Another way we can do that is use a class called iterator to do that. And please tell me you're going to give me code. All right, so we'll start here then. You have your vector v.begin. So every container has a dot begin and a dot end. The dot begin points to the first element of the container. Dot end points to the last element of the container. So you create an iterator that starts at begin and keeps going down until it reaches end. Notice that you can have multiple iterators running through a vector if you really felt like it. All right, here we go. Are they going to do it? They are. Perfect. So let's go ahead and print via iterator. And let's just go up here and copy pasta this. Copy pasta. 4. Here's the good old syntax. So first off, you have to get the correct class. You have to call iterator. I'm going to call it I. And then we're going to start it with ira.begin. Notice that got a lot more complicated. That's okay. Let's go jump to a new line just to make it hopefully clear. I does not equal ira.end. And then each time you're going to increment the pointer. Okay. Well, how do we print this out? Let's go ahead and get this guy right there, and we'll jump and put this guy down here as well. Great. Well, you actually just dereference it. All right, let's see if that worked. Yep, there it goes. What do? Let's start again. We create the iterator. Notice that the iterator class is part of the class you're iterating over. So that's how you access it. And the reason for that is each iterator is going to behave differently depending on the container. So the iterator for a vector is internally going to work differently than over a list, because obviously a list, you're going through a linked list, while a vector, you're going through an array. If you're going through a hash table or a tree, the iterator is going to work differently. So that's why you have to have an iterator for each class. It makes sense to just make it part of the actual STL class to begin with. It starts at the beginning, so that's why you call .begin. And you keep going until you're at the end, and the end is always one element after the last. Yeah, there you go. It's always one element after the last. So never try and dereference the end. You can always dereference the begin, but never dereference the end. A little couple of confusing looks, so let me go back to the picture. Notice over here, v.begin pointed to the first element, v.end pointed after the last element. No, it's going to point to something after the element. In a vector, it's going to point to the memory address after the last one. But in a linked list, yeah, if you're using a vector, it'll be after the last one. But a linked list or a binary tree or something else may be whatever else it is. It's going to be something else that tells you you're at the end.
But in the linked list, it still won't point to null?
It may or may not. The point of using an iterator is that they are encapsulating the implementation. So you don't care what's happening in the back end. It's just as long as you adhere to this interface, it's working. So yeah, great.
So I guess if you wanted to like just print out all the numbers, like an iterator would be like just a standard way to do that?
Yeah, the iterator is the standard STL way to do it.
Okay, and then I'm guessing with the way it's laid out, if you want to do more than just printing or do something with every number, I guess that kind of
Right.
helps that.
Yeah, because notice that with this iterator, after every iteration, I did plus plus to go up by 1. I could do minus minus and go backwards.
And then start at end?
Yeah, I could start at, well, end minus 1.
Yeah. Okay.
Yeah.
Okay.
Yes.
Is this done internally with an enhanced order? Is that what's going on?
Oh, so notice C++ overrides operators. So when you do plus plus, it has its own implementation of what that means. So that's how it moves iterator to the next point. For a vector, you're pretty much just using a pointer, a simple pointer. But since it's an object, hash map or a hash table binary tree might be something else. Yes.
So just double checking,
That is
operator?
undefined, but yeah.
That, yeah, that would just return like, you said memory addresses, right?
Yes, because the iterator is really a pointer.
Okay.
Well, hold on, I take that back. That's not what I said. The iterator for a vector is probably just a pointer, but they have overloaded the plus plus, and they've also overloaded the dereference operator.
Oh.
So they've changed the meaning of what this actually does. You understand what it's supposed to do because you're used to using pointers, and that's the interface that they are adhering to. But they have changed what this actually does and what this does to some other implementation. They're encapsulating the implementation. They're hiding the implementation from you because you shouldn't have to worry about it. It's just going to behave the way you expect it to. All right. Okay, great. That's nice. Let's see, iterators. Okay, start and stop. This is another example. What's that? I think the for loop really explains everything, but do y'all see, well, what is this one doing?
Just going through a vector and finding the maximum number.
Going through a vector, yes, of integers and finding the maximum one. And then stops when it's at the end and then returns it. Hey, look, this is what we just coded. What would this print out? Yeah, 12, 3, 17, 8. All right, everyone following so far? Once you get vectors, the rest of this is going to be a lot easier. Okay. So not every iterator can be used with every container. For example, the list class provides no random access iterator. So with the iterator, you could, with a vector, you could jump wherever you want to. With a linked list, obviously that doesn't make much sense because you're using a linked list. So there's different types of iterators. They divide them into 5 categories. Right now, we're going to be using bidirectional and random access. There are 3 others if you start delving into other things, but for now, it's not really important for this class. But do keep that in mind if you ever have to use C++ and you have to use the STL. There are other types of iterators. Oh, I'm sorry. Random access, you can jump wherever. Bidirectional, you can go forward and backwards. Forward, you can only go forwards. And then input and output have to deal with, well, is it input or output? Streams. Okay. Now, did y'all do for each in Java?
No.
Y'all have never seen for each?
Yes.
Yeah, for each. Yeah.
I think we made it in C++.
Oh, okay. Oh, you did?
Right? Where it's just, you have like the type, like a variable, the colon and.
Okay, let's do it this way. Print. I mean, this one's going to be interesting. For each. All right. And isn't this part of algorithm? Yeah, it is part of algorithm. That's what I thought. Because it's for each, which is kind of weird. Array.begin, array.end, and then what was the next syntax? Apply a function. Oh, you have to have a function. We'll call it my print. All right, first off, we have to include algorithm. And then since it's, because this is an algorithm, we're calling a function, we also need to create the my print. Ooh, what's the syntax there? Just the value? Okay. All right, let's see if that worked out the way I expected to. Wow, first try. Probably should put some quick little comma space. All right, there we go. So it prints it out. Hey, it even printed it out in order. So for each, you give it the beginning iterator, the end, and then you pass it a function to call on each value, is what it's doing. Now, syntactically speaking, or I guess thinking about it, did it have to do this in order?
The best at the beginning and the end, so logically.
Probably, but does it need to? What if you wanted? What if you had a huge, let's say, a huge vector, and the function you're calling is doing extremely complex notation? You know, it takes about half a second, but you have 20 cores or 24 cores. Could it do it in parallel? It's kind of a tough one. Well, let's look up here first. Let's look at our old way of doing it. Can this take advantage of 20, extra cores? Let's say that this right here was a very complicated statement. It took half a second to complete, just for the sake of argument. Does this for loop take advantage of multi-core at all? No, not really. How about this one? Nope, because you're doing it one at a time. All right, this one, again, no, I'm going to help you here. No, not really. But now that we have for each, it's not telling you what loop or mechanism it's doing behind the scene. It could call, split it out into 20-something different process threads, I'll say, and then execute the first 20 on each one, then go to then batch the next 20, or you can just do it in any random order. Since you're just saying for each, you're not actually telling it the order. Yes.
It'd be like with different iterators.
Yeah, it could use different. Well, it could use the same iterator. Usually, the way it's done, you have your master thread, and then as it goes to each value, it sends it off. So you can think of it as forking out an iterator for each one. Yeah, that might be a good way to think of it. So this one, while syntactically, also syntactically, it's a little shorter, possibly, because your function. Also, the other nice thing is your function that you want to operate on each. Or I'm sorry, what you want to do to each data element is a separate function, so it kind of makes your code a little cleaner in a way. Might be another advantage. But then you're running a for each algorithm, so who knows how it's working in the back end. So this is more of a give and take. I'm not going to be testing you off of parallel processing, but I want to make sure you at least see what's going on, because that's parallel processing is definitely more of an advanced topic. All right, any questions with for each? I'm not grading you over for each, by the way. That usually means no one has a question, I've learned. Find. Oh, okay, I bet you'd like this one.
Ooh, wait.
What's that? All right. So let's see. We want to find. We're going to do iArray.begin, iArray.end. What value do we want to look for? 14. All right. I always forget the syntax here. What does it return? It returns an iterator.
Yeah.
Okay.
Iterator to the position of that.
Yeah, an iterator to the position. Yeah. I'll call it position. And then if position does not equal iArray.end, what does that mean? Yeah, it means it's in the array. So all right, let's see if we can find 14 in here. 14 was found. Great. Well, let's see if that works. We go negative 14. Was not found. Right. Well, I guess you can't print out 0. So, was not found. Let's just say.
I can't print out what?
Well, I tried to print off the value, say it was found, but obviously position, if it's not in there, it's not going to find it. So there, it was not found. Great. Okay. Any questions about find?
So you're just giving it the range with the first two parameters and then what you want?
Mm-hmm. Why would it be a range? Ooh. Why don't you just pass the container?
Oh, because it doesn't know the size.
Well, vector can tell you the size. You have vector dot size.
But what if you want to like search it and small?
Yeah, there you go. Yeah. What if you only search the first half of it, or the second half, or only some portion of it?
But you can still use it because there's different functions for finding different ways to write it, different structures.
That's true. That's true. But I'm saying, why is this one probably the most generally accepted way of doing it? It's because you can smaller spaces.
I guess also from a programming standpoint, it makes you keep that in mind.
Yeah, that's true too.
So
You're
what was it?
a little more explicit in what you're doing.
I tried to use that on a project and I kept getting issues.
Oh.
So I ended up throwing it out the window basically.
Oh, okay. Great.
I did use it, but only for the strings, so I can cut down everything.
Okay.
I didn't use it.
Hmm.
So I thought it's in it.
All right.
Especially for-
Also, once you find an element, and if you want to find or see if there's another one, you can try, instead of passing begin, because remember position's an iterator. So now you can say, starting one after, can we find something afterwards as well?
So is the plus operator also?
Yeah, it's all, yeah, they overload everything. Whoops. All right, find if. Ooh, I forgot what this one did. Oh, okay, so they're just parameterizing the test to be a function. So let's see. Let's say bool is even. Return val %2 equals 0. All right, great. So we can take, actually we'll stick with that, and then we'll go down here, find if, again, IRA.begin, IRA.end, and then is even. All right, and then we'll just do, say, we're just going to do it, I'm just going to pretend like there's a value in there. Is even.
Well, the reason it's gonna
It's just going to give you a 0, yep. 18 is even. So let's go ahead and make that little if check at the beginning. If this does not equal IRA.end. There we go. So it says 18 is even. Is that the first even? Yep. So if we wanted to find the second one, $14 is even. Let's change the 14 to a 15 just to show that it is actually changing things up for us. Yep, and then it found 32 that time. Okay. All right. Count if. Okay. We'll do the same thing. Sure. Why not? It's good to show things 3 times. That should return a value, actually, doesn't it? Doesn't it return an integer? Yeah, so we're just going to print it out. Found. Found 3 even values, is that right? Yep. So again, could the algorithm in the background take advantage of multicore if it wanted to? Probably. Because it's not, you don't have, it's testing each value individually. So if that function was very complicated, it could take advantage of multi-core. All right. Okay, any questions on vector? Because now that you see how count, find, and all those work, those functions are also going to work for all your other containers as well. For the most part, yes.
Can you have a vector of vectors?
Yes. And what is that actually?
Well, a multi-dimensional array.
It's a 2D array. Right.
So we can have vector of vectors of
Vector for 3D arrays, so forth and so on. Yep. Yeah. Yep. So the list is a doubly linked list. It's great. Hey, it works just like a doubly linked list. Huh. So it's going to behave kind of like a vector, except you're using a linked list instead.
And that's where we would use our handy-dandy computer science knowledge of what is good for what, even though they kind of look the same, right?
Yes.
Yeah.
Yeah. Yeah, that whole degree thing you're getting, right? The whole degree thing, right? Yeah.
I'm sure for funsies now.
Let's do this for fun. Okay. All right. So we have two arrays. We create a linked list from both of them. Looks like they're the same. Hey, look, you can copy one array to the. Oh no, they're making one from the first and the other one from the second. You can copy, what was it, into the range into L2. So that means that L2, even though it originally had 2, 4, 6, 8, 10, will now be 1, 3, 5, 7 because you copied it over. Nice. Any questions on this one? Hopefully, now that I've done 3 of the find if, and count, hopefully these are going to make a lot of sense because they're all going to basically behave very similarly. Okay, what do we have? Whoops. Oh, different inserters. So we're not going to get too much to inserter. You can write your own inserter if you want to. But your back inserter inserts it at the end, front inserter appends it to the beginning, and then you can also just insert it at some location. So notice back inserts it at the end, aka append to end. So while it started with 2, 4, 6, 8, 10, you append 1, 3, 5, 7 to the end. Front inserter, use the front. Notice how it inserted it because it's always appending to the front, so it's like it's shifting it over and moving one extra in there each time, which is fine because it's a linked list and that's not hard to do. Y'all see how these two differ? And then what was the last one? You insert. Oh, copy, insert at the very beginning. So it inserts 1, 2, 3, 4, 5 at the beginning, and then it ends the rest. Okay. Any questions, comments? Screen. Great. Hey, look, we have sorting and merging. Hey, they have L2.sort. I wonder if that's in the array as well, or the vector. I bet you it is. I didn't actually think it was a member function. Let's find out. Whatever. Print via. Yeah, I thought you had to do the. What was it called? Well, let's do it the old way actually. Via iterator is what we want. Yeah, I thought you had to do it with start and begin. Yeah, I didn't think it was part of it. I thought you had to do this. There it goes. Hey, look, it sorted it. Which sort function did it use? Does it matter? No, it doesn't matter. But in general, it uses quick sort. Well, actually, it depends on your data structure. It depends. It depends. All right, so we can sort. Hey, look, that's great. Hey, and you can even call merge and merge two lists together.
So does it remove the elements from the second list?
Yes.
Oh, it merges it in with one.
L2 is empty.
So will we have
It'll automatically delete it for you because notice that the class, or the object, sorry, was instantiated on the stack, so when it goes out of scope, it'll automatically be deallocated. Unless you did new, then you do need to delete the object.
Okay, there we go.
But all the internal deletions are handled by the object itself. Let's see. We've already talked about giving a function. Okay, so a sort you can create your own way to, I guess, sort. So you can call greater to base it on greater than, and write your own function to sort it by any wacky thing you need. This actually makes sense if you, for example, if you're trying to sort a bunch of students and you want to sort them by some of their attributes, maybe either by their name or by their ID, then you could write your own function to tell you which is greater or less than. All right, function objects. Okay, this is nice. We just did this. Accumulate everything. What's this? That's positive? Oh no, accumulate. Add everything. So add all the values together into sum. Or you could use multiplication and multiply everything into a variable. Hopefully that doesn't go past the size of the integer. All right, this is how you actually, good, we got the code out. You want to do the squared sum? This is what you would do if you wanted to overload one of those functions. You create a separate class. It has one function called operator that's passed two values, and then you just return what the next value should be. You have to adhere to this interface if you want to be able to do this. Notice that since you're overloading the open close parentheses, this makes sense. Oh. Yeah, yeah, it's weird. This is why overloading operators sometimes gets wacky. You're like, wait, this doesn't, what's going on? But it's overloaded. You're overloading it.
Like logically squared sum would be a function.
Right, right, but it's not. It's actually a class that you're overloading the, yeah, the stand, what the that bracket means. Yeah. Oh well. Again, I'm not testing you over this. That's why we're not going into too many code examples. All right, sure. So you can do it with complexes. Oh yeah, if you can template things as well. Yep. Notice that you had complex. We could do it with integers or doubles. That's perfectly fine. All right. Associative containers. I pretty much just explained this on the board, but hey, let's talk about it again. It's not arranged in a sequence. It's just stored somehow, usually as a tree or a hash table. The main advantage is the speed of searching. So every time you search, it's usually either binary search or better. Searching is done via a key, just like up there. You'd search for a key like John or George and try and get a value, like an ID back. It has two basic associative arrays. You have sets and multi-sets, and you have maps and multi-maps. A multi-set just allows you to have multiple items in the set, which kind of contradicts the point of the sets here, but whatever. Notice you're not really appending or you have a subscript per se. You just insert. So right here with a name set, and it looks like they're going to organize it on called less. That's great. So they go ahead and have an array of strings, and they add those 5 to a set. Then they insert Patrick, Maria, and Juan. And then there's a good old iterator. Put in a name, tries to find it, and if it's found it, yeah, it's in the set. Otherwise, it's not in the set. This is usually what sets are used for. You have a list of something, and you want to know, is someone a member of it or not? And if they are, grab it and let's do something. That's very common to use a set for. There are other couple things, because in math you do have, or they're not going to do it. Well, anyways, oh no, set and, right, so you can iterate up to a certain level. So what they're saying here is they start with upper K, and go to upper Q, and you can iterate all the names that are in that value. Okay, great. They're not going to do it, tell you. So just like mathematical sets, there are algorithms to do unions and intersections as well. Yes?
The string names already has some pretty interesting names. I'm pretty sure Hedwig is just like, I don't know, a Harry Potter fan. Hedwig. the
Hedwig,
bird.
okay.
And Guido. Is that something anyone would name their kids by any chance?
I don't know. When you all name your kids, your kids.
Like Italian.
I mean, someone was named Olga, so I mean,
Olga.
right?
And then we got Olay. Like what? What? I'm pretty, yeah, that's
It's
a
Ole,
great.
it's just Ole.
That's a greeting, not a name.
It's Oli.
Oli,
Oli.
people would name their kids that. I'm sure Ollie's name's been used. I'll do it just to make a point. Look, y'all are just you're just Americans, and that's the problem. You gotta get out.
That's the. Okay.
Not just culturally insensitive. Yeah, that's the word. Yeah, that's it. Which you know, I'm actually okay with. Just
Yeah.
it's just when people take offense to it. I'm like, really, guys, get over it. Yeah, we're jerks.
That's what we are.
Yeah, we think the globe is just the U.S. and everything else is water. That's just how it
Is
works.
it?
Yeah, isn't that the way it is?
No, there. It's okay.
Yeah.
We'll help you.
All right. Anyways, so a map stores a pair of key values, similar to what I'm showing up here. A key contains, well, a key, so you can search for something. So now you have names, you're associating them with numbers. Oh, wow, that's starting to get interesting. So your phone book, right? Your phone book's going to map a string to an integer, and we'll order it with less than. And then you have an iterator from it. Notice that it's the same thing as up here, but with iterator. So phone book sub name sub j's equals numbers. So that's how you initialize the phone book. Notice that they're going to say phone book sub 75643. Or I'm sorry, not 75. I'm sorry. Phone book sub Ole equals 75643. And then phone book sub Hedvig equals 83268, et cetera, et cetera. That's what they're doing right here. And then here, this is how you iterate. Notice with this iterator, since it's a map iterator, you have a dot first and a dot second. The dot first is going to be the first thing, aka your key, the name, and the second one will be the value, integer, the number.
So the iterator for a map consists of two parts.
Yeah, it has two parts to it. Well, you still iterate it the same way, but when you use it, you have a dot first and a dot second. Notice here, if you just want to search for Lars's phone number, it's just phone book sub Lars. That's it. Oh, good, that's the end of it. All right, any questions here? I'm going to go over the lab, and then we'll do our ethics paper, hopefully real quick.
Ethics paper.
We're going to do an ethics paper.
They
English?
assign it to us, we gotta do it in class.
Well, we have to talk about it, and then